2.4a, the chain rule. This is probably the most important rule or thing that you'll learn in your math. You will have the chain rule in everything you do in math from now on until you stop doing math. All right? It will be in there. All right? And so this is what happens in our chain rule. It's when we take a derivative of a composite function. So if I have f of g of x, if I have f of g of x, I have an inner composite g of x going on. But I take the derivative of the outside. So what's the derivative of f? F prime. And so I have f prime of g of x. However, I need to take the derivative of that inner composite. And so I need to take the derivative of g of x, which is g prime of x. All right? It's kind of like gears. One gear turns the next gear. And that gear turns the next one. And so forth and so on. Or it's kind of like these creepy stacking dolls. All right? Uncle Arnie gave them to me. I didn't know they were so creepy at the time, but anyway. All right? So, what happens with these Russian stacking dolls? Nesting dolls, whatever. What happens? If I take out the outside,
there's another one inside.
What do we have?
Basically,
we have another one on the inside.
Oh.
And then what? After we take out the outside, we have another one on the inside. And then we could do what?
Do the same thing again.
We can take out the outside, and there's another one on the inside.
And
then what?
Repeat as needed.
Alright. Alright. So anyway, that's the chain rule. We go outside, and we're starting to keep containing the derivatives on the inside. So I want to talk about the innermost composites of these. So if I have 1 over x plus 1, my innermost composite is x plus 1. And so I could kind of think of that as just the base function of like 1 over x, or 1 over u in this case. So if I have sine of 2x, what is the innermost composite? 2x. 2x would be my innermost composite. So I could kind of think of the outer composite of sine of u. All right. If I have this square root of 3x squared minus x plus 1, what is my innermost composite?
X.
What? Exactly, all that inside function. All right. And so my outer composite, my outer function, is just the square root function. And then if I have tangent of x squared, what is my inner composite?
X
squared.
What? No.
Tangent x.
Tangent. It's exactly. It's tangent x. And so my outer function is really x squared, or u squared in this case. All right? So I want to do this next one, and I'll do u substitution, but then I'm going to show you that you don't really need it. All right? So here we go. I got y equals x squared plus 1 quantity cubed. So what is my innermost composite? What's my u?
X squared plus 1.
X squared plus 1, right? And so I can kind of think of this thing as like y equals u cubed. True? Mm-hmm. So if I take a derivative of it, I could say dy dx is equal to, what would be my derivative of u cubed? 3u squared. But then a u prime pops out. And so I need to find u prime. And so u prime would end up being what here? 2x. And now I would back substitute everything. So now I would have dy dx is equal to 3 times, what's my u? X squared plus 1 squared. And then what's my u prime? 2x. And then the only thing I would do is simplify it up a little bit. The 3 and the 2x play together and give me what? 6x times x squared plus 1 squared. All right?
So
right.
for the dy dx equals 3u squared, is that times u?
U prime.
Okay.
the derivative of u. All right. All right, so I want to show that you don't really need that. All right, I want to show that you can just jump there without doing u substitution. When we start going backwards, u substitution is very necessary. But when we take derivatives, I really don't think it's necessary, and I just want to show you how to do it quickly. So I'm going to find my derivative. So I have this y equals x squared plus 1 quantity cubed, right? So let's start using my outer to my inner. My outer function, and then I'm going to take the derivatives of the innermost composites. So what do I bring down front? A 3. And then I have x squared plus 1. And by the power rule, what happens? It becomes what? A 2. And then, because of my chain rule, I take the derivative of the innermost composite. So what's the derivative of x squared plus 1? A 2x. So a 2x pops out. And one thing I want you to caution you on is that this is being multiplied. Okay, it's not being added. Does everybody hear that? All right, it's being multiplied. It's still with it. So now, all I would do is simplify it up with the 3 and the 2x to give you what? 6x, and then I have x squared plus 1 squared. And so there is my derivative. All right, pretty cool? All right, let's keep moving. Keep moving. So here we go. So now I have f of x is equal to the quantity of 3x minus 2x squared quantity cubed. So, how do I notate taking a derivative? F prime. So my outer function is really u cubed, right?
Yes.
And so my innermost composite is this 3x minus 2x squared, right? So what goes out front?
3.
A 3. So now I have 3 times 3x minus 2x squared to the power of 2. But then by the chain rule, what pops out? 3 minus 4x. Very good. All right. And the only thing that I would change up about this answer, to simplify it just a little bit, is I'd probably bring this 3 minus 4x out front, and I'd just leave it like this. All right, I wouldn't go any further. Now, some people might multiply by 3 and say 9 minus 12x, and then times that quantity squared, but I don't think it's necessary, nor do I think it's beneficial, because the factored form is actually probably better. All right. Yes, go ahead. I want to talk about how you've kind of been doing the chain rule all along. I want to do one, and you've kind of been doing the chain rule the whole time. So if I have f of x is equal to, let's say, 3x squared, right? And I want to take a derivative. What would be f prime? 6x, right? Well, what really is happening is I have my innermost composite is x, right? And so what's the derivative of x? I bring down my 2 to play with the 3 to give you 6, right? And then I have x to the power of 1. But then I take the derivative of x, which is also what? 1. But do we actually need to show that? No. All right? And so really you've kind of been doing it. You just didn't know because it's been 1 the whole time. All right? All right, let's look at this next one. We're going to find all the points. What does a point need? An x and a y. All right? Of the graph of f of x is equal to the cube root of the quantity x squared minus 1 squared, for which f prime of x is equal to 0, and f prime does not exist. I know this isn't asking, but I'm asking it. What does it mean when f prime of x is equal to 0? The slope is 0, but let's go further than that. What does it have? A horizontal tangent line. And that thing's going to be extremely important as it keeps going on with us. All right? All right, so here we go. I personally would manipulate f of x first. All right? I don't want it to look like that. So I'm just manipulating f of x, so I need to say that it's still f of x. So how could I say x squared minus 1 to the what? 2/3 power. All right, I'd highly recommend you manipulate looking like that first. Now let's take a derivative. So f prime would equal what? What needs to be brought out front?
2/3.
A 2/3. And then I have x squared minus 1 to the
Negative 1/3.
-1/3. And then I'm done.
No.
Oh, I forgot my chain rule. What do I need to bring out? A 2x. All right? Because the derivative of x squared minus 1 is 2x. Don't ever forget the chain rule. You're going to forget the chain rule, but I'm going to keep saying don't forget the chain rule. All right? All right. Yes?
Why is it?
All right. So what gets to stay up in my numerator? 2 and a 2x. So 2 and a 2x combined to give you 4x. So now I have 4x times, or over, 3x squared minus 1 to the power of 1/3. All right? And so there is my derivative. And what am I going to do with that derivative? Set it equal to 0. So I'm going to set f prime equal to 0. So I have 4x over 3 times the quantity x squared minus 1 to the power of 1/3 equals 0. So when does that happen? X equals what? X equals 0. All right. However, did I answer the question? No, I need to find the points. So what do I need to do to find the points? Substitute back in. So I need to find f of 0. So I substitute back in right here. So 0 squared is 0, minus 1 is -1, -1 squared is 1, cube rooted is 1. So I have a point of 0, 1. And that's when I have a horizontal tangent. Now let's find when f prime does not exist. So when does f prime not exist? When x equals what? 1 and when else? And -1. So I want the points though. So I need to find my y values. So I have f of -1 and f of 1. Well, what is f of -1? 0. And what's f of 1? 0. So my points are -1, 0, and 1, 0. All right? And so that is where f prime wouldn't exist. All right? They would be sharp turns.
Yes.
All right. Good. So here we go. So now I'm going to differentiate g of t, which is equal to -7 over the quantity of 2t minus 3 squared. Now I'm going to go two ways to Tampa on this one. I'm going to show you both. And after I show you both, do I care which way you go?
Nope.
Not really. I'm going to go one way because it's quicker. But you can do whatever way you want. What rule could we use? We could use the quotient rule. So I'm going to show you the quotient rule, even though that's the long way. I'm going to show you the quotient rule. So how do I notate taking a derivative? G prime of t. So I would take the derivative of the top, which would be 0. And I'm just going to write it. Times the bottom. Minus the derivative of the bottom. So what needs to be brought out front?
2.
A 2. And then I have 2t minus 3. Does anything else pop out? A 2. And then times what? -7 times the top. All over 2t minus 3 what? To the power of 4. What do we get up top? This goes to 0. And then what does -2 and 2 and -7 become? 28. So now I have 28, 2t minus 3, over 2t minus 3 to the power of 4. Now, does anything else happen? The 2t minus 3's cancel. So that cancels, and that becomes 3. So now I have g prime of t, which is equal to 28 over the quantity 2t minus 3 cubed. All right, pretty good? All right, now I want to go a shorter method. Okay. How did something get to the basement? It was a negative power. So I want to say g of t is equal to negative 7 times 2t minus 3 to the negative second. All right? And because I had a constant in my numerator, this is a very quick way to Tampa. All right? So let's take a derivative of that. So g prime, negative 2 would come out front with negative 7 to become what? 14. And now I have 2t minus 3 to the power of what? Negative 3. I'm subtracting 1. And then I'm done. No, I forgot the chain rule again. What needs to pop out? 2. All right. And so what's out front? 28. So now I have g prime of t is equal to 28 times 2t minus 3 to the power of negative 3. But really a negative, where does it go? The basement. So g prime of t is equal to 28 over 2t minus 3 cubed. All right. Pretty good? Did we both get to Tampa? Yes. Does it really matter which way you go? No. I personally like the right way better. I think it's a little bit quicker. All right. Pretty good? All right. There you go. Also, page 128, numbers 111, 112, and 120. All right. Those are just graphs of f, f prime, and f double prime. Okay. So I want you to continue to think like that. What's a derivative? Slope of a tangent line. All right.